My name is Arif Zedi, and this video is about the execution of the code that I wrote in Python in Google Colab for assignment number 2. This program performs hyperparameter tuning on a neural network using the Cipher 1800 dataset. The training and test portion of this dataset was provided separately by our professor. It loads the dataset from Google Drive. These datasets are in the Google Drive. Defines the search space for hyperparameters and trains models using different configurations. The best performing model is selected based on validation. Accuracy and results are visualized using a line plot. Finally, the script saves the results and plots to the Google Drive for further analysis. So let me go through the code briefly so that you have an idea what different libraries have been used and how the flow looks like. These are all the Python libraries that I'm utilizing. These are the Torch, the PyTorch libraries, the Pickle for reading input data, NumPy, Pandas, CPON, a Matplot library, and skitlearning, intuitive tools, TKDOM, and Google Drive library, google.colab. First of all, it connects to the Google Drive, and I provide the credentials, and then it loads the data from the Google Drive, the train DB and the test DB, and after that, it basically kind of it assigns the X train and Y train and X test and Y test using the label and the features that where the label is the target, and basically then it encodes it using the encode one hot encoder, and then basically it transforms the Y train and Y test, and it converts the X train, Y train, Y test, and X test into the tensor so that it can be used for our calculations. Here we define like a neural network. Basically, it has got like three hidden layers function where we are basically invoking this like a simple NN class. And basically, here's the criterion. We are using the cross entropy, and basically and this is how we are initializing the optimizer and checking if the optimizer is Adam. If it's not, then we just use this the parameter that we have defined. And here we are just basically using the CPU. I've got a Google Colab, so you can use the GPUs also. But sometimes the GPU is not available, so the best thing I thought was to use the CPU. And here we are using epoch. We are using from 1 to 5, and basically we are basically running it like 5 different times to train the model. And basically this is the parameter grid which is used to train the model. And this is here we're basically assigning the data, loading the data into these four variables. And here we are plotting the five, we are giving the best hyperparameter combination and the best overall accuracy, and we are plotting the figure to show the code results graphically. Let me execute the code. I think it takes around 4 minutes to completely execute the code. So please be patient. So let me start executing the code. This is my previous execution. So once it starts executing, these all will go away and then it will start fresh. I have like a private links to the Google Drive, but when I will submit, I'll use the public links so that you can run the code without having to log into the Google Drive. So now it's connecting to the Google Drive, and it's gonna upload the training and test DB into separate parts in the code. I started doing the training. So there are like 16 possible combinations based on the hyperparameters, and so it's going to try all of them, and then it's going to display the best hyperparameter along with execution time, the best overall execution. You're seeing is trying different combinations of the hyperparameters and doing the training across 5 different intervals and calculating accuracy each time. Give it another minute or so. It's in its final stages now. So here is basically the after going through all these iterations, like it found that the best hyperparameter combination was this one, uh, basically, and the best overall accuracy came out to be 31.15%. Here is the line graph. This is for the ReLU. These are different cup. We are using two hidden activation, the ReLU and sigmoid. So this is for the ReLU and this is for sigmoid. And you can see the best overall accuracy is somewhere here, and it is around 31.15. So that concludes my video. Thanks for watching my video. Bye.